Hi dear students, in this video we are going to study about applications of determinants, and we are starting with the Cramers rule. Cramers rule is working on the system solutions, and we are using for system solutions like given here. And after this system, we learn that one also. You can write the coefficient matrix, and each entry becomes the coefficient of the variables here. And then the solution of matrix AX should be equal to B. Here A times X is equal to B. Also I explained that one in the matrix form. Then Xi is equal to AI over A. It's going to be where X is equal to X1, X2 variables, and B is equal to B1, B2, Bn. It continues like that. Like if we are talking about X1, then by using the Cramers rule, AX1 divided by A, it might be, or if we say, let's say we are looking for Y, then by using the Cramers rule, AY divided by determinant of A, it should be determinant of AY divided by A, it's going to be. And then the question is coming, what is AY? How to find the AY or AX here? And here, this is the answer of the question. How to find the AX? This is, firstly, it is equal to AX, which means that you are replacing in the main matrix. This is the main matrix. Let's say A1, A2 determinant, also you can say A1, A2, A3. These are the coefficients B1, B2, B3, C1, C2, C3. This is the main one. And then if you replace the values of the coefficient of X, actually coefficients of X, if you replace, then you will get here AX. When I switch this one by this values, which is equal to here D1, D2, dx, as I showed here, D1, D2, D3, I'm sorry, then you are going to get the AX matrix. This is when you replace the values for the Y. This is AY matrix, or determinant of AY, determinant of AX, and determinant of Z here, AZ it's going to be. So X is equal to AX over A, Y is equal to AY over A, and Z is equal to AZ over Z, A, it has to be. Okay, let's solve with one question. This one, to find the system. Firstly, I have to write the matrix A. Let me write the matrix A, which is equal to, or determinant of A directly. Let me write, because 2 minus 1, and here minus 1, 3, it has to be. If it is like that, the resultant matrix, I'm going to use the term D. D is equal to, ladies and gentlemen, it's going to be equal to 3 and 1 here. I'm going to use as a matrix this one. Then I'm going to replace the values in, firstly, if I'm going to find the AX, which is determinant of AX here, it's going to be, you're going to replace the 2 and minus 1, which are the coefficients of X, by 3 and 1. Now I'm switching the coefficients of X, 3 and 1, not minus 1. 3 and 1. This part stays same, which is equal to 2 and 1 and 3. Actually, it's better to write the determinant of A here one more time, which is equal to 2 minus 1 minus 1 and 3, because I need to find the determinants of all these expressions also. Here, let's continue a bit down. Okay. Then here we are going to find the determinants, and AY, let me write, then I will find the results here, is equal to, this time I'm going to switch the coefficients of Y, which is minus 1 and 3, by 3 and 1. 2, minus 1, 3, and 1 it's going to be. Then it's going to be equal to, here, I'm going to calculate now determinant of all these expressions. 2 times 3 is equal to 6, and minus, minus 1 times minus 1 is equal to 1, which is equal to 5. It has to be. Then this is going to be 3 times 3, it's equal to 9. And minus, I'm putting 1 times minus 1, it's going to be equal to minus 1. So 9 minus minus 1, which is equal to 10. It should be 9 plus 1. And the last one, it's 2 times 1, it's equal to 2, minus 1 times 3 is equal to minus 3, which is equal to 5. So determine the value of x after these operations. I can say like this: x is equal to ax over determinant of a, which is equal to 10 over 5. That's equal to 2. What about the y value? Y is equal to ay over a, it has to be, that's equal to 5 over 5, which is equal to 1. And if you replace the values in the equation, like here, if I replace this one by 2 and this one by 1, then the result becomes 3 also. I need to tell that one for the solution also. Okay, let's continue with 3 by 3 matrix. For 3 by 3 matrix, firstly I have to write the A matrix, which is here. I'm going to write like A is equal to determinant of A is, let's say, is going to be equal to 3, 2, 3, 1, minus 1, 2, 3, and minus 3, and 1 it's going to be. What about the D matrix? This time matrix as a matrix I'm writing. There's no need to write minus 1, 0 it's going to be. Then here, this is the matrix D. Now I have to calculate one by one for each term. Firstly I have to calculate AX here. First I have to calculate, A, then AX, and then we are going to continue here. First I'm going to calculate A. A is equal to, I'm rewriting the matrix here, 2, 3, 1, minus 1, 2, 3, minus 3, 1. Then I'm going to choose the row as a, I have to choose one row, and I'm going to choose the first row here. If I am choosing the first row here, I'm going to do like this. That reminds me that I'm going to use the entries in that row, which is equal to 2, the coefficients are 2, 3, and minus 1 to the power of 1 plus 1 times the, when you close first row and first column, the minor it becomes 2, 3, minus 1, and 1. This is the first part. Second part is plus 3 times minus 1 to the power of 1 plus 2 times the entry of first row and second column. When you close, the entries are minus 1, 3, and minus 3, and 1 it's going to be again. And the last one, it's going to be equal to plus 1 times minus 1 to the power of 1 plus 3 times when first row and last column closed, third column closed, minus 1, 2, minus 3, and minus 3 are the entries it's going to be. So this part, it's going to be equal to 2. This is minus 3. It should be minus 1 to the power of 3. And this should be again 1. So if I rewrite the terms here, this is going to be equal to 2 times, in parentheses, 2 times 1, 2, minus 1 times 3, it's going to be equal to, I'm sorry, here this should be 3, not minus 1, minus 3, because 2, 3, minus 3, 1. I made a mistake, yeah. And the answer is going to be equal to here 2 minus 9, then minus 3 times the, when we open the parenthesis, minus 1 times 1, it's equal to minus 1, minus the sign minus 3 times minus minus 3 times 3 is equal to minus 9, it's going to be. So here it's going to be equal to, this is going to be equal to 8. This is going to be equal to 8. This is going to be equal to 2 plus 9, which is equal to 11. And the last one, it's going to be equal to 1 times in parentheses minus 1 times minus 3, it's equal to 3, and minus 3 times 2 is equal to minus 6, it has to be. And then here it's going to be equal to also 3 plus 6, which is equal to 9, it's going to be. Then I'm going to shortly write 2 times 11, it's going to be equal to 22. Minus 3 times 8, it's going to be equal to minus 24. And 1 times 9 is equal to plus 9, which is equal to 7, it has to be. So here, after all this operation, I can write like this: a is equal to 7. Then I have to find step by step ax and ay. First I'm starting with ax. Then I'm going to write for the ax, first I'm going to switch all the values, all the entries by 2, minus 1 and 0. First I'm writing that one, 2, minus 1 and 0. Okay. Then 3, 2, minus 3, 3, 2, minus 3. Then 1, 1, 3, 1. It has to be. Then it's going to be equal to, I have to choose one row or one column. I'm going to choose here the first column, because when we have the entries there, when we have the 0 there, it's easy to calculate. So I'm going to write like this: 2 times minus 1 to the power of 1 plus 1 times the entry is 2, 3, minus 3, 1, and here plus, it's going to be equal to 3 times minus 1 to the power of 2 plus 1, because it is second row first column, times, and the entry values are, when you close, 3, 1, 3, 1, and minus 3 and 1 it's going to be. Then the last one is 0 times minus 1 to the power of something it's going to be, but here since it is 0, everything here it's going to be equal to 0. That's why I'm going to continue with (28) it's going to be. By the way, I found the 28, but I didn't find the value of x. Value of x is going to be equal to determinant of ax divided by determinant of a, which is equal to 28 over 7. X is equal to, I have to write here, x is equal to 4. It has to be. So we are going to find now y is equal to a y over determinant of a y over a determinant of a, which is equal to minus 21 over 7. Y is equal to minus 3. It has to be.